Okay, in this video we're gonna look at exercise web crawler. In this exercise you'll use Go's concurrency features to parallelize a web crawler. Modify the crawl function to fetch URLs in parallel without fetching the same URL twice. Hint, you can keep a cache of the URLs that have been fetched on a map, but maps alone are not safe for concurrent use. Alright, so this is one of the hardest exercise in this whole a tour of Go, I think. There's so many things going on this. Okay, so first we got interface. So in this interface we got a fetch method basically, right? So interfaces are I don't know, like these are not like implementation, they require implementation. They're like a template, not exactly a template. I don't know the exact word, but they can be used as types or something like that. So this tells you to what makes a fetcher. If anything implements the fetch, they are a fetcher. So fetch returns the body of URL and a slice of URLs found on that page. Okay, so fetch takes URL, which is a string, and returns body, which is also a string, URLs, which is a slice of string, and error. So it returns three things. Crawl uses fetcher to recursively crawl pages starting with URL to a maximum of depth. Okay, so the function crawl takes URL, takes depth, which is an integer, and a fetcher. So we got to do fetch URLs in parallel. Don't fetch the same URL twice. So this is what they want us to do. This implementation doesn't do either. If depth is 0, if depth is less than or equal to 0, return. So fetcher returns the body URLs error. So that's what we saw in the implementation. And if error, so this is just error handling, nothing special. And then they print URL body. So looks like the fetch, right? Fetcher fetch. How does the fetch work? So fetch already returns a array of strings which are URLs. So this URL, okay, wait a minute, what is URL? So we get URLs, but we have URL here. Where is the URL? So URL, so URL is like initial page. So basically what this is doing is you give it a URL and then it goes through the page and looks for URLs. So essentially any links, you can find it if you like you have like HTML document, and you can just search for anchor tags that contain href. You'd know this if you ever work with web development or HTML or whatever in general. So they're not like, they're just hardcore the values at the end, so it doesn't really matter. So this is the initial like page we are supposed to crawl, and the body, so some like body or something, and then we range over. So we get the URLs. So first initially we go to a website, we get all the URLs, and then we crawl those URL again. We crawl on those URL again, but this time we decrease the depth by 1. So eventually the crawl is gonna just return. So these are just recursively calling crawl, calls crawl. So this is just recursion. So after this, it's gonna just end. It's gonna like finish this loop, exits out of loop, and completes the function. So we got the main function. They're crawling the main. So this is the URL they're trying to crawl, and the depth is 4, and they using the fetch function. So we got fake fetcher is a fetcher that returns canned results. Okay, fake fetcher is a map of strings that return a pointer to what is that? A pointer to fake result. Okay, fake result is a struct. Think of it like a object or something. It holds body and URLs. So fake fetcher implements the fetch method. URL strings return string error. So calls fake fetcher accessing the URL. So fake fetcher, what is this? We got something like, so F, what is F? F is fake fetcher, and they're using bracket, square bracket to URL. Need to ask ChatGPT what the hell it is, bro. What the hell is F URL? F URL is map indexing syntax in Go. In the crawler example from Go2, fake fetcher is defined like wait a minute, dude. I'm looking at the fake result. I was like, what the hell? So this makes sense. Like, if you are trying to access like fake result with this syntax, it just doesn't make any sense, right? How are maybe we could, like, if I had a struct, maybe like how do I access it? Maybe like call the instance of fake result and maybe use the bracket notation. I don't know. So fake fetcher is where is it? Fake fetcher is a map. So accessing map using square brackets, it's common, so makes sense. So accessing map, we get the result or okay. So if it's okay, this is just a short statement. So this is the condition. Return rest body and rest URLs nil. So where is this getting rest body? Rest, where is rest? Okay, so they're getting the rest. So rest body, rest URLs nil. So rest body is the body, URLs the URL string, nil is the error. So if we didn't get anything, we return the body is empty, URL is nil, error is not found. Fetcher is a populated fake fetcher. Fake fetcher contains, okay, so it's just a body and URL, right? So we got a body, Golang arg, and the URL is pointer. So what is it? Okay, wait a minute. Fake fetcher. Fake fetcher, we need to fake fetcher is a map. Fake fetcher. Okay, this is the key and this is the value. The values are a pointer, fake result pointer. So they use fake result. So they're just passing the address of fake result. They create a fake result and they just pass the address. So they're just passing the value. So essentially, right? They're not copying it. So fake result, they're creating the fake result. Fake result takes a body and then strings. So something like this. So essentially they just created a fake fetcher, like this is just map, right? So this is a pre-populated map. So there are a lot of things going on here. All right, let's try running this, see what happens. What we got? So we got some stuff. So initially it goes to the Golang arg, the Go programming language, and then it finds the PKG link, and it finds the Golang arg, and then it finds the PKG, and it doesn't find the link. So yep. All right, let's delete this and try to rewrite it. This is gonna be tough. Let's see. Let's create a node. Crawl. Let's call this crawl requirement. Let's call this crawl requirement. First, what do we need? We need a fetcher interface. This fetcher's interface job is fetch method. Fetch method returns, takes a URL, returns a body, array of strings, and error. Okay, this the and then crawl. And then crawl, and then we have a crawl. So what's it? Crawl takes a URL, takes depth, and what fetcher. It takes a fetcher. what does it do? So yeah, so the first thing it does is return, let's just call this exit function if depth is 0. Fetch the URL, fetch the URL, get the body, array of URL and error. If error, print the error. What do we want to do next? Nice. Print the error. Okay, exit the function. If error, print the error and exit the function. So essentially we don't even continue with the operation. So yep. And what do we want to do next? So next print the body and URL. Next, recursively call crawl again with okay, we need to loop over it, loop over the URLs and crawl again. Patience, bro. Okay. Finally, just return. So this is the whole function. What are they doing? What are these goofs doing? Fake fetcher is a fetcher, returns a map and a result, a map of fake result body URL. So we are only interested in body and URLs, right? We need to get body and URLs. Question is how? What data structure can we use to store body and URLs? So I would usually think like objects, but Go doesn't, like in JavaScript, usually like if you want to store like body and URLs, you automatically think of objects. But in Go, you need to automatically think about struct. So we think of struct, a struct that holds body and URLs. So we somehow need to return a struct, a body and URLs. We need to like remember, like the fetcher only needs They only care about body and array of URLs and error, optionally error. So we need to return these three things, although we are not holding the error though. So if you had a struct, like if I had a object in JavaScript, I could like deconstruct it, right? Let's see how. If I add a struct, how do I get values from it? So we got a user struct, and we create the instance of the struct, and we can just access it like this. If I have pointed to the struct, you name automatically. Cool. Come on. Wait a minute. Can we not for structs like JavaScript in JavaScript? Okay, we can do that. Go as no struct destructuring syntax. You must access fields individually. Are you struct directly? Go does have a limited form of destructuring for multiple return values. It only has a destructuring for multiple return values, but for map, okay, it does for channels, okay. So Go does not have so essentially we just need to use the dot operator to get the value from the struct. Okay, just a hint. So hint, this is not something we need for the algorithm. This is for whoever reading this in the future, hopefully me. So we call the fetcher. Somehow it returns a body, an array of URLs, and error. So what they are doing is they're like, so they basically like you pass a URL. What they do is they store this URL as a key in a predefined map, and they just look into the map, get the value. The value contains all the things you want. You got the body, you got the strings, and but it doesn't have error. So what they do is, if they don't find it, they probably return an error. So this is what they're doing. So they're taking the URL, they look into the map. When they get the result, this is the fake result, and they send you the body request URL and nil for the error. So yeah, So what's the flow? Crawl search uses the URL to get body uh, array of URLs error. We take the URL and find the use it as key in the map. We take the URL and use it as a key in the map and get the result. The result contains body URLs. If we don't have the key in the map, then we don't return, we return empty body. A nil for the array of URLs and error message. How are they constructing error? So this is a formatted error. So it's just a way to create an error, although it does look like a something you would print on the console, but FMT is a very big package. I think it also contains how to creating error objects. So this is just a formatted error object. Okay, so now we got basically the requirement. I think you should probably skip this video. It's gonna be like boring. Okay, let's start with let's start with package main func main. On top of this, I want to create interface. Use type. What was that? Fetcher. It was called fetcher, which is an interface, only contains fetch, which takes, what does it take? Probably takes URL and probably returns URL, which is a string, and then returns a body, which is a string, returns URLs, which is a array of string, and error. Yeah, what the hell? Okay, got it. We need to give it a variable name or something. Okay, fetcher, we got a fetcher. This fetcher as a method, what is it? So we got an interface fetcher, and this as a method, right? Cool. What are the requirement? So fetcher as a interface, fetch as a method, takes URL, returns body. Then we got a crawl, takes a URL, depth fetcher. Okay. Now we need to create a crawler. Crawl takes a URL, which is a string. Okay. It takes a depth, which is a int. I think that's pretty much right. And fetcher, it takes a fetcher, which is a fetcher. Oh shit. So what does it do? First it checks if the depth is less than or equal to 0. Immediately returns, right? Immediately returns. And then calls the fetcher with the URL. Cannot call fetcher. Fetcher is not a method. Okay. Fetch. Need to call the fetch. What's going on? Quick fix. Didn't really do anything. All right. So we're supposed to call fetcher fetch with the URL. This returns body, URLs, and error. Okay, first error, we just handle the error. We print some like println some error, bruh. And then we immediately return. Then what do we do? Next, we probably like print fmt, println. We print the body. Let's say print f. Let's say body is, where's the hell is percentage body, and the URL. Body and URL, and then we loop over it for range URL. URLs is a slice of strings, so we don't want the index, we want the value. And then we crawl, pass the value, but the depth -1, and the fetcher, pass the same fetcher. Although we have this expected one expression. Yeah, we are supposed to like use this. And after everything is done, we return redundant return. What the hell was that? I'll just keep it, bro. So we need to create a map. Let's call this fake map, because that's what it is. It's a map. So there's a map, that was string, and a pointer to fake result. So okay, I think we need to put this in a function or something, or in the main. Okay, why is this? Why are we getting? Okay, declare not used. Okay, that's fine. Okay, it's freaking out because we don't have fake result. Okay, fake result is a struct that holds body, which is a string, and then URLs, which is a array of string. And now it's freaking out. Why? Wait a minute. So we are assigning something. We're assigning fake map. Why? It doesn't even contain any value. We're using it like so they're using this as a type. So what is this weird type? Anything can be a type. Okay, let's ask ChatGPT why this is wrong. Why is this wrong? Why is this wrong? Because you are only specifying a type, not creating a value. This is like writing x c is int. Ghost is a type where it's expecting a value. If you want to create an empty map, make map or if you want an empty map, we can create it either using the make function or just using the braces. So if we want to define a type, we need to use it like this. Notice the key type keyword. This creates a new named type called fake fetcher. So having a type is handy because we can create methods on that type. So let's call this fake fake map. Fake map as a fake fetch. Takes a fake map. Fake fetch implements the same thing as URL, takes URL and returns all this same goofy thing. So let's just copy this. Take okay. This is too small for this, bruh. So what are we supposed to do next? Okay, we got the fake map, fake fetch. What does it do? It just takes the URL and looks in the map, and this gives us a result. This res is for start for a response usually. So result okay. If it finds, so what they're doing is they're using this as a short expression in if condition, and then they use the okay for the check, and if it's okay, they return body. Where is the body? So res body, res URLs, and the error is nil. If it's not okay, they just return empty body, nil URLs, and fmt error f. I'll just call it error. So that's pretty much it. So you use the f to specify like a format specifier or something. Let's also use the error, like pass the URL. So okay, so we got everything set up. So let's call crawl. Although we do need to instantiate fake map. We need to where is it? We need to create the fake map. So let's copy all of this. Let's call this fake fake map we got a fake map, then paste everything. Fake result. Let's use Control D and just fake result. Okay. So now everything should work, I think. So we got the fake map. This fake map has a method called fake fetch. So let's see if this okay. So we got everything correctly set up. So we need to call crawl. Let's for the first value, let's use this go arg. The depth is 4. Fake map as fake fetch. Multiple value fake map, fake fetch, value of type. What is going on? Okay. We need to ask ChatGPT what the hell is wrong, bruh. What's wrong? The problem is probably with this call. Fake map, fake fetch is a method value, a function, while the go-to class usually expects a fetcher interface. Okay, interface, something like interface, where type fetcher, your type as fake fetch. Notice method name is fake fetch. Interface expects fetch. So fake map does not implement fetcher. Rename the. Okay. All we need to do is just rename it, bruh. So we're supposed to call this fetch. We're supposed to call this fetch. Although now it just doesn't make any sense, right? We're calling this fake map as fetch. Jesus, doesn't make any sense. How can a map have a fetch method? You tell me, bro. Now we just call fetch. Okay, now what? Fake map as an interface. Okay, we're supposed to pass the pass some type fake map here that as a fetch method, fetch implementation. So it takes this instance, fake map instance, and where it does, so it calls the fetch method. All right. Okay, it's working, but since we're not using new lines and shit, and when it doesn't find anything, it just says some error, bruh. So that's not really a very good print statement retrospectively. Doesn't tell anything. So my bad. So what is this? Let's call nothing found. And year, body, URL. Okay. Also, let's add new lines everywhere. Okay, now body, the URL, body URL, nothing found, nothing found. Okay. Ends with a redundant new line. Come on, man. So essentially, we just rewrote the exercise. Didn't do anything. So we're supposed to now we are supposed to modify the crawl function to fetch URLs in parallel without fetching the same URL twice. So we need to use channels, function, go routines and shit. Okay, function, crawl function to fetch the URL in parallel. So our task, what is our task? Let's get it. Let's copy and so we're supposed to fetch it in parallel without fetching the same URL twice. Fetch URLs in parallel. So the fetch function needs to be run. Fetch function needs to be run in a Go routine. Multiple Go routines will run it without fetching the same URL. So map. So we need to understand how a map works. So map, how does it work? How does a map work? It has a key and it has a value. So when we are fetching a URL, what do? So we get a body. Every time we fetch a URL, we get a body URLs and error. So we can put this in a map. So we can check if a URL exists in the map don't fetch it, right? Let's do it. Let's try to do this. So we got a loop. Where is it? Where's the crawl? We're gonna call the crawl with a go routine. So what does it map? So we need to keep a map. Let's say we got a map visited map, which is a map string that holds result basically. Type result, which is a struct. Come on, man, come on. Which is a struct that has body, which is a string, and then URLs, which is a string. Do we need an error? Okay, let's also put error. So what we need to do? We're gonna need to create a empty. So we need to create a empty like in the main. Come on. Let's copy this. We need to instantiate an empty map. So here we need to create an empty map. And boom. So we got an empty map. This crawl should take a map. We could, instead of using the map, we could use the channel too, right? Channel does not really like old values. It's just values like go through the channel. So it's not something you use it to hold values. So let's make our crawl take a map. So it now takes a map, although like it takes a M, which is a map of a string result we're gonna pass the M. So here we pass visited map. Yeah, we need to pass the value, I think. What's going on? Yeah, we need to, let's see, take crawl. Let's put an asterisk here. Cannot use visited map of value as the argument to crawl. Why? So what is this? So visited map is a fake result. So empty fake result, say takes the same thing. What's wrong? Why can't I use visited map? Because the types don't match. Your crawl function expects in the main string result, but in the main you created fake result. You're kidding me, man. You're kidding me. Jesus Christ. Okay, now let's go to. Okay, now if. Okay, we need to append a value to the map. Map append. So we got append method. Append to m. What we need to append? How do we append? Like how do you add value to the map? How do you add key and value to the map? Is the map index visited map? Okay. Okay, so first we check if so when we try to access a map like m with URL, right, cannot index m variable of type. So even though we have a map, why can't I do this? Why can't I do this? Okay, a pointer does not, so this fails because Go sees you need to dereference the pointer first. Jesus Christ. So we kind of need to dereference this goofy shit, man. Are you kidding me? This weird syntax. Now we should declare but not used. So if obviously we fetch the URL. If the response is okay, then we append, we use the URL or something. Do I need to use the dereferencing thing here too? Or no? Like assign URL for the body, we need to create a result. So the body is as a wait a minute. So it is a body. Hopefully it doesn't shadow it. Okay, we have a nice shorthand. We can just put it like this: body URLs and nil. Nice. So we're just gonna ignore the rest. Wait a minute. What are we doing here? If the rest is not okay, so when is it okay? So map returns okay if it has a value already in it, right? So if it's not okay, we put the value. We are already fetching here. Okay, we need to check if we need to like use the same thing and check the map. So do we have a value or something? So let's just grab this. So what does it mean? So we are looking for the URL, and there's a URL. Then how do we continue? How do we continue? How do we skip that? So this needs to be in the for loop. So can you use the continue here? So if there is if there's a URL in it, continue, don't crawl, don't call this crawl. And if there is nothing, so this should already avoid the repeatedly calling the same URL. What's going on? So are we like so what's going on? Like we call the first thing should return string this, and then so the first call should return these URLs, right? PKG and CMD. We should get that. But so the URLs should be PKG and something like that. Oh yeah, the URLs should be V. Okay, now okay, so body, the URL is this, and we have something like the URL. Okay, we got one URL, unique URL, another unique URL, another unique URL, another unique URL, nothing found. So we got nothing found, right? Error. What do we get? Error. So for the error, Let's just print the URL too. Let's print the URL. So this needs to be unique URL, but if it's unique URL, when do we return an error? We only return an error if it's not in your fake map. So there's a URL that's not in our fake map. I get a nothing found for a URL. Why? The nothing found is probably for CMD because it's referenced here. So we got a here and we got another one here, but you never added an entry for it in the fake map. Your map contains these are the key values, FMT, but not CMD. When crawl reaches CMD, it executes this fetcher fetch, which calls fetch and all this and runs. Since the key doesn't exist, you return an error and then prints this. There's also a subtle bug here. You're storing the result before checking for errors. Wait a minute. You're storing the result before checking for errors. If fetch fails, you are still inserting into the map. Cleaner order. So put this after the error check. Okay. So where is it? All right. So nothing found runs. Since we call the same CMD URL 2 times because we didn't save it in your visited map. What did this goofy ChatGPT say? The crawler is working is just that your fact database doesn't contain. ChatGPT is tripping me. my first implementation was good. It even tracked URLs where it couldn't find the result. How do I add a parallel thingy for this? You're very close to the ghost. The parallel thing is coroutines plus a sync wait group. Right now you're doing for loop, which is sequential. To make your crawl concurrently, use the go, but then main exists before the go routines finish. That's why you need a sync wait group. Sync wait group. Basic pattern, sync wait group, add function. Okay, for your crawler, pass a wait group at the start. Defer done. In the main, we need to call the wait group, add one, and pass the wait group, and then here, so we have a loop. Okay, we just need to figure out where to put this. So we're really close. So what we gotta do is just we need to get hold of our wait group, sync wait group. So now we have a wait group, and the crawl needs a wait group. So it takes a wait group. It takes a wait group, which is a pointer to sync wait group, which is a pointer to sync wait group, and the here it says defer wait group done. Crawler takes the wait group, here let's add a wait group, add one, wait for done. So we just need to wait for this to be done, and let's pass the wait group and call go. So this literally launches however many URLs we found. It just creates these go routines depending on the URLs. More we might need to use the worker patterns so we can kind of keep the go routines in control. So we don't want although we can create as many go routines as we want, but we can't just let them run. We could let them run however they want, but it's not probably recommended pattern. The recommended pattern is the object pooling pattern. All right, so should probably fast or something. So we got a negative wait group counter. Uh, okay, wait a minute. We're supposed to use something like wait or something. So it only ran body found. What the hell? So where are we supposed to uh, put the done? So let's see what's wrong here. What's wrong here? The biggest problem is that you are launching coroutines but never incrementing the wait group counter for them. You do add crawl wait, and inside crawl define done. So the counter goes add 1, done 0. Meanwhile, though these coroutines are created, but you never did. Are created go crawl 0, but you never did go add 1 for them. So wait can return while those coroutines are still running, or worse, a coroutine may call without a matching add 1, causing panic. You need a There's an even bigger issue. uh what is this? So I'm just adding value to the map and are accessing the map from multiple coroutines simultaneously. Go maps are not safe for concurrent access. Soon you will get something like concurrent map read and map write. You need a mutex. All right. Oh, bro, we need to create a mutex. Sync mutex for the safe map, and then every read and write must be protected. And lock, unlock. Another subtle issue can start after another coroutine has already visited the URL. This means two coroutines can both see at the same time and both crawl the same URL. The usual fix is lock check visited, mark visited immediately, and lock fetch all as one protected operation. That's why the official solution wraps the visited map in a struct with a mutex. So your current bugs are missing add 1 before each go crawl, concurrent access to visited map, race condition causing duplicate crawls, fix first, then you will start seeing the concurrency bugs from 2 and 3. Yep. I'm gonna stop here and we're gonna fix this later.